Hello everyone, welcome to the channel Pharmacology Simplified. In this video, we are going to discuss about neurotransmission. When we talk about neurotransmission, it is the process where neurons communicate. Now, these neurons, they can communicate, like the communication can be between neuron to neuron, or it can be between neuron to any effector. So, for example, we have the NMJ, neuromuscular junction, which we will be discussing in the later videos in the channel, right? So, when we talk about neurotransmission, then there are several things that we need to understand. First is we have to understand what is action potential. Then we have to understand depolarization, as well as we have to understand repolarization. One more thing, membrane potential. So we would first discuss these two terms, action potential, and they are also called as impulses. So like single is impulse, right? So now we would discuss in detail what is action potential and what is membrane potential. So when we talk about action potential, then this action potential, we can say action potential and impulse, we can say that these are a series or sequence of a very rapidly occurring events, right, that reduce and reverses the membrane potential, and ultimately they bring it back to the resting state. Let me simplify it. So when we see like action potential, it comprises of two steps. First is depolarization, and second we have a repolarization. So for understanding this, see, for example, I guess we all are familiar with the structure of a neuron. So let me first simplify that. For example, if we take this as a neuron, these are its dendrites. So what happens? That these dendrites, they accept the signals. The signal is processed here in the cell body. This is the axon of the neuron, and these are the terminal ends. This is the axon. This is the cell body, and these are the dendrites. The basic function of the dendrites is to receive the signal, right? The basic function is to receive the signals, right? Cell body's function is to process them. Axon, it conducts, and these terminal ends, they convey. So this is the actual direction of the movement, right? The dendrites will receive the signal, cell body will process it, the axon will conduct it, and these terminal ends will convey this signal to another neuron or to effector, right? So let's move ahead. So if we see, like this is our neuron, right? So this is our neuron. This is the extracellular side and this is the intracellular side. On the extracellular side, I think this is very clear to all of us that there is very high concentration of sodium ions. So with this, I am making a legend here. This is sodium. So sodium ions concentration on the extracellular phase is very high, and on the intracellular phase we have potassium ion, right? So since the concentration of sodium is so high outside, right, this is sodium, since the concentration of sodium is so high, this leads to generation of a potential difference. This leads to generation of a potential difference, and this outer side of membrane has positive charge, and this intracellular side, it has negative charge. Now what happens? So this is the what we are witnessing right now. This is the resting state, right? This is the resting state. That means there is no impulse conduction. Right now, no impulse is being conducted in this region. Whenever, for example, we put a rest here, right? So this is like there, since there is a separation of charges, so we can call it as polarized state. Polarized state. High sodium outside, high potassium inside the cell. So this is the polarized state or resting state. So whenever you have impulse, there are channels, right? There are channels, specific channels. So these are, for example, we consider them, these are the sodium channels and these are the potassium channels. Sodium, and these are the potassium channels. So what is happening? As soon as an impulse comes, we get, I am denoting this impulse by I. As soon as there is arrival of an impulse, these sodium channels, they get activated or they get opened. As soon as they get opened, this sodium, right, this sodium rapidly comes inside the cell. We say it as sodium influx. This sodium is coming inside the cell very rapidly. This is very rapid. This is happening. One more thing I would like to elaborate here. If we see on a graph, the potential. See, this is the time and this is the action potential. So for example, here we have the charge 0 or not 0. Let's say this is the charge of minus 70 millivolts. This is 0 millivolts and this is 30 plus 30 millivolts, right? So at this point of time, this very stage 1, here it is moving like this, it is going straight, right? So this is the polarized state. And when I talk about this stage, when I talk about stage 2, what is happening during stage 2? There is depolarization, and when there is depolarization, what is happening? There is influx of sodium, right? We are seeing that this sodium is getting influx through these sodium channels, right? And when this sodium is getting influx inside the cell, we can clearly see that since sodium is having positive charge, the influx of sodium is so rapid, this reverses the polarity of the membrane. This reverses the polarity of the membrane. And what happens now? We can clearly see that since the charge inside has risen, this starts to move, right? This starts to move up, and it overshoots to approximately plus 30 millivolts. It doesn't stop here, right? It doesn't stop here. It overshoots to 30 millivolt, and when it reaches 30 millivolt, what happens? This state is known as depolarized state. Now we have high sodium and high potassium inside. Polarity is reversed, right? So now the charges, the negative charge, it has gone out and the positive charge is inside the cell, right? So now the impulse, now our impulse, it has moved ahead. So our impulse that was here, it has moved ahead. Next, in the next step, when we see these potassium channels, they start to open up. These potassium channels, they start to open up and they lead to efflux of this So what is happening now? These sodium channels, they have become inactive, which implies that there is no movement of sodium inside. And these potassium channels, now they have opened in response to this change in polarity. Since this polarity has changed, now these potassium channels will open up. So now this potassium that was previously present inside the cell, now it will tend to move out of the cell, right? This will start to move out of the cell, and when this will move out of the cell, since potassium is having positive charge, right? So what will happen? This will start to fall. This will start to fall. So now this phase, this is the third phase. Now we call it as repolarization. So there is high sodium inside and less potassium inside, because this potassium has moved out of the cell, right, for the process of repolarization. This sodium is inside the cell, but in the previous stage, in the resting stage, like if the neuron is supposed to conduct again or it has to transmit the impulse again, what it has to do? It has to again regain this stage, this resting stage, this stage has to be regained, right? Then we have this a period, and we call this period as refractory period, right? This refractory period is the time period where the neuron cannot conduct. Even if we get an impulse, like here the impulse was arriving, so even if we are getting an impulse here, this neuron will not conduct any impulse. So this is called the refractory period. Let me explain what happens during refractory period. I guess we are clear with this one. So during the refractory period, right, suppose this is our neuron. So I hope we all are familiar with sodium potassium ATPase pumps, right? These are the sodium potassium ATPase pump. What they do, since they are sodium potassium ATPase pumps, what they are doing, since they are ATPase, that means they are transporting against the concentration gradient. What? They are transporting against the concentration gradient. So in the last stage, what we had seen, in the last stage we had seen the sodium, right? The sodium concentration in the cell has increased significantly. But in order for a neuron to conduct again, this sodium has to go outside. But since the concentration of sodium is already very high outside the cell, so this transportation process cannot occur just like that. Hence this ATPase pump comes into picture, right? what they will do? They will transport against the concentration gradient. That means they will transport from low to high. This is active. And if this is high to low, this is, we call it as passive transport. So what happens? This sodium pump binds 1, 2, 3 molecules of sodium, and when it binds 3 molecules of sodium, it changes its shape, right? It changes its shape, and during this period of time, what happens? There is hydrolysis of ATP molecule. This ATP is converted into ADP, right? That means there is phosphorylation of this pump. This means phosphorylation is activation of this pump, and now what it will do? It will show a conformational change. That means there will be a change in the shape of this pump, which will allow these three sodium molecules to be pumped outside the cell. And as soon as these sodium molecules are pumped outside of the cell, what happens? That potassium molecules, right? We remember those potassium molecules that have gone outside during the repolarization phase. Now what they do? They bind two potassium molecules, right? Two potassium ions. What they do? They bind to this, and as soon as there is binding of these two potassium ions, this phosphate molecule detaches now. Now this detaches. This phosphate molecule detaches. And when it detaches, what happens? This pump regains its original shape. This pump regains its original shape. That means it is again ready to pump these sodium molecules outside and bring potassium molecules inside. So while this sodium and potassium, they are being exchanged, during this period, the neuron cannot conduct at all, and this is called as refractory period, right? So I hope we are clear with this concept of depolarization and repolarization and the refractory period. In my upcoming video, in the very next video, we would be discussing in detail about the process of neurotransmission. So at this point, I would like to end this video. I hope you have been able to understand what I have tried to convey to you, and do mention in the comments like if there is anything that I need to change in my videos. Happy learning to all of us. Thank you very much.